We are going to Zahar, please unmute. Zahar, unmute, mute பண்ணிக்கோங்க. So today we are going to see the topics from Engineering Physics Laboratory. So we are in first year, first semester. Our subject code for Engineering Physics Laboratory is a UDPH CPA. So this code is for all the non-DG courses. For a first semester, we have to consider 10 experiments. So for first cycle, we are going to consider first 5 experiments. For the second cycle, there are another 5 experiments. So we are discussing about torus and pendulum. So in the last lab, we have studied about the rigidity modulus of elasticity of the given material by using torus and pendulum method. Today we are going to see a topic Newton's ring. By using this Newton's ring method, we are going to measure the radius of curvature of a convex lens. So by using the Newton's rings, so this Newton's ring experiment is almost similar to the air wedge experiment. The Newton's ring experiment is similar to the air wedge experiment. How it's similar? So in the air wedge experiment, instead of convex lens, we used plain optically transparent glass plates. So we have taken 2 glass plates of same property. Then we placed these 2 glass plates one over the other. One end of the glass plates is tied with the help of a rubber band or a thread. On the other end, we introduced our specimen. So by introducing the specimen, we are getting an air wedge. That air wedge is the air gap. So when light falls on the air wedge or air gap, as a result, we are getting interference pattern. So from that interference pattern, we measure the thickness of the given material. Here the thickness is in the range of microns. So the micron level thickness are measured with the help of the experiment air wedge. For today's experiment, Newton's ring. So here also we are going to form an interference pattern. With this help of this interference pattern only, we are going to measure the radius of curvature of a convex lens. The experimental procedure is almost similar to the air wedge. So what we have considered, the procedure to find the thickness of the given material by air wedge, the same procedure with a slight modification, with the slight changes. Here we are going to follow for the Newton's ring experiments to measure the radius. So let's see the experiment. The aim of the experiment, it is used to determine the radius of curvature of given lens. So the lens here used to be convex lens. So here we are going to use this convex lens And also we are going to pass the light radiation to falls over this convex lens. When the light falls on this convex lens, it produces an interference pattern. The outcome interference pattern is in the form of circle. So here we are going to get a circularly based interference pattern. What is this circular based interference pattern? Interference pattern means superlap of the two waves. So we are going to imagine that two waves are going to be superimposed with each others. When the two waves are superimposed with each others, as the result, an interference pattern is obtained. So the interference pattern is an alternatively bright and dark fringes. So we are going to see a black line, then yellow color, then a black line, then yellow color. So alternatively black, yellow, black, yellow, black, yellow. So this is a pattern. So when these alternatively colors are obtained over the telescope through the eyepiece section, then that obtained pattern are called as interference pattern. So we are going to first determine the interference pattern. With the help of the interference pattern, we are going to measure the radius of the given material. That is, we are going to measure the radius of curvature of the given convex lens. So the apparatus requires sodium vapor lamp. Sodium vapor lamp is the light source, the monochromatic source of radiation going to fall over the material or convex lens. Traveling microscope. So when the monochromatic source of radiation falls on the convex lens, it suffers interference pattern. So that interference pattern is obtained or it's viewed with the help of the traveling microscope. So these are all the just a material medium. The convex lens is a material medium. Glass plate. So the glass plate is going to be used for the inclination. So the glass plate is going to use as a base, and also the glass plate is going to be used as an angle of inclination. So we are going to use a glass plate at an angle of 45 degree. The glass plate inclined at an angle of 45 degree. When it's inclined at an angle of 45 degree, then when a monochromatic source of light falls over the glass plate, it undergoes the reflection. That a reflected image falls on the convex lens, then they will transmit and they will just return back. So these waves are superimposed, transmitting rays and the reflected rays superimposed, and as a result, we are able to see the interference pattern with the help of the traveling microscope. So this is the experimental formula. Experimental formula is very simply given here. R is the radius of curvature of the given convex lens. R is equal to capital R is the radius of curvature is equal to R square n plus 9 minus R square n. R here, the small r is the radius of square. Radius of square. So here we are going to consider an interference pattern in the form of rings. So the radius of the rings, we are going to have a n number of rings here in Newton's ring. From that n number of rings, we are going to consider radius for the position n plus 9 and a radius for the position n. So it shows that we are going to consider only the difference. We are going to measure n number of readings. We are going to measure 15 readings, for example. So out of that 15 readings, we have to collect the differences between, or a difference between n and n plus 9. So here the range, the order is the n minus n plus 9. So this we are going to measure from the obtained interference pattern. So here n plus 9, I have given here as n plus 9 in the formula. If suppose I am writing here as n plus 3, then here we have to write 3 lambda. Here suppose I am going to consider n plus 5. Here I have to consider 5 lambda. So the based on the order, based on the difference, here we are using the term n 9 or something. So lambda is the wavelength of the given source. So we are using sodium vapor lamp. For sodium vapor lamp, the value is already given. It's a constant value, 5893 or 96 into 10 power minus 10 meter. So the formula is very simple. The experimental also is very simple. The only difficulties the students will face in the laboratory is the focusing. So they have to do this experiment properly in order to obtain the interference pattern to get the circular rings. Once the circular rings is obtained, once the circular rings is viewed by the student, then the experiment becomes very easiest for them. So this is a procedure. The formula R is equal to R square n plus 9 minus R square n by 9 lambda. So let's see the experimental procedure. So this figure shows the experimental procedure. See, here we have considered a sodium vapor lamp. So this sodium vapor lamp is a light source. Here the value for the sodium vapor lamp lambda is given. Wavelength lambda is equal to 5896 into 10 power minus 10 meter. Then we are going to consider a traveling microscope. So this traveling microscope is used to view the Newton's ring and also to measure the readings. So with the help of the traveling microscope, we are going to catch the interference pattern, circularly obtained interference pattern, and also by using this instrument microscope, we are going to measure the readings. So this is the purpose of the traveling microscope. Then we have taken a glass plate. So this glass plate here, it's just seems to be it's located in open air space, but in general it will be not like this. So this glass plate is placed on the stand. So we are going to consider a wooden stand, so in which this glass plate is inclined at an angle of 45 degree. Then inside the wooden stand, we are going to place the plain glass plate. Above the plain glass plate, a plano-convex lens. So this is the test medium. Plain glass plate and a plano-convex lens is a test medium. So this medium is placed inside the wooden base, in which a glass plate is inclined at an angle of 45 degree. So this is a procedure. So what we are going to do, we are going to place this entire setup, wooden frame, then a plano-convex lens, 45 degree inclined glass plate. This entire setup is fixed or placed in front of the light source. And with the help of the traveling microscope, we are going to visualize the changes. See, when the monochromatic source of radiation is falls on the glass plate, a light radiation, here it falls on the glass plate. We know that it is an electromagnetic radiation. So it has a spherical format. It falls in all the direction. It falls in all the direction. But our consideration, our aim, so we have to focus the light radiation on the particular target. So to make the light radiation to falls on the just a medium, test medium, plano-convex lens and the plain glass plate. So we are placed the glass plate inclined at an angle of 45 degree. Now, so radiation, when it falls on this inclined glass plate, it gets reflected. This reflected light passes through the plano-convex lens and then it goes to the plain glass plate. So when the light radiation strikes the surface of the plain glass plate, it again undergoes the transmission. That is transmitting ray. This one is a transmitting ray. When it falls on the plain glass plate, it will reflect back. So these reflected back ray here are shown in the upward arrow mark. So we have to just think that the rays, transmitted rays, as well as these reflected rays are superimposed with each other. So we are having two types of rays here. Transmitting ray, the transmitting ray is just falls on the glass plate, then it falls on the planar convex lens, then it goes to the plain glass plate. When it strikes the bottom surface of the plain glass plate, then it will reflect back. So the transmitting ray and the reflecting ray are superimposed with each other. When the two rays are collide with each other, when the two rays are bombard with each other, when the two rays are attracts with each other, then as a result we can obtain the interference pattern. That interference pattern only we are going to view here with the help of the traveling microscope. So this is experimental procedure. So I will just explain this once again. Considering a sodium vapor lamp, so these radiation falls on the glass plate inclined at an angle of 45 degree. Then it will reflect from the glass plate. Then the ray transmits through the plano-convex lens, then to the plain glass plate. When the ray strikes the bottom surface of the glass plate, it will again reflect back. So the transmitting ray and the reflecting ray superimposed with each other. As the result, interference pattern is obtained. We can able to see that interference obtained circular pattern with the help of the traveling microscope. So the same illustration, but in enlarged way. So what I have shown in the previous figure, the same I have taken here also. Now you can able to see the difference. The S is the source, monochromatic sodium vapor lamp. The light falls on 45 degree inclined glass plate. Then it reflect. Then the reflected ray transmits to the convex lens and then to the glass plate. So here we are having the downward arrow marks. So these are downward arrow marks. The arrow marks which are towards the plano-convex lens shows the transmitting ray. When the ray strikes the bottom surface, it will reflect back. The upward arrow mark shows the reflected ray. Here these two rays are superimposed, collides with each other. As the result, due to this superimposition, we can able to see the circular format in the right side. So here we are having another one figure here, not an experimental figure, but this circular pattern is the outcome. So when we view the traveling microscope, we can able to see these circular pattern. So these circular pattern is the interference pattern. Here we are having a dark spot, then a white spot, then again a dark ring, then a white ring, then again a dark ring, then a white ring. So alternatively, continuously we are having the dark white, dark white, dark white. So this is the interference pattern. So here in this third figure, bottom figure, we can able to see that what is the transmitting ray and what is the reflecting ray. So R1, R2 are the reflecting ray, T1, T2 are the transmitting ray. So these the changes. So here we are having a gap. So the gap is induced between the plain glass plate and plano-convex lens. So in between these two, we are having an air wedge, air gap. So when the light falls on this air gap, as a result, we are getting this interference pattern. So this is the exact outcome. So when you are doing your experiment in our physics laboratory, you are able to see this structure as your output. So what I have just shown here in the previous slides, the same we are getting as an output. So this be the original. This be the original one. So here the circle, we can able to see the circle. So inside the circle, we are having an n number of layers. Inside the circle, we are having an n number of layers. So we can able to see n number of just circles inside this whole circle. The center, then first circle, second circle, third circle, fourth circle. So here we are going to consider the left and the right side, not the top and bottom side. We are going to consider the left and the right side. And with the help of the traveling microscope, with the help of the eyepiece section, so in the eyepiece section, we are having two cross wires, vertical wire and the horizontal wire. So here our consideration is from left to the right, not from the top to the bottom. We are going to consider from left to the right. So the left to the right is the horizontal base. The left to the right is the horizontal base. You can able to see that left, right, it's horizontal. Top, bottom, it's vertical. So we are going to consider only the horizontal. So for the horizontal base, we have to consider the vertical wire. We have to consider the vertical wire. So we have to place the vertical wire in any side of this ring, any portion of the ring, and we have to start our reading. So this is experimental procedure. So I will explain you how to measure the readings and what the changes will happen. So the experiment which we are going to use to measure the readings. So this is the Newton's ring experiment traveling microscope. So the traveling microscope is the basic medium, is a major medium here in the Newton's ring, because without using this traveling microscope, we are not able to obtain the interference pattern. And if we want to know the radius of curvature of the lens, so we have to take a reading. So here the readings are going to be measured with the help of this instrument, microscope. So here you can able to see the parts of the microscope. Eyepiece section. So here this is the eyepiece section. So here only we are going to place our eyes and you are going to measure the changes. So here we are having a screw. In this eyepiece section, we are having a screw also. So by adjusting this screw, we can make this eyepiece section to move down and the up to get a clear image of the Newton's ring. So in the eyepiece section, we are having two wires that I have also shown here. You can able to see at the corner of the right side, vertical wire and the horizontal wire. So we are going to consider only the vertical wire. So we have to place this vertical wire at any one point of the ring. Then we have to measure the readings. So how we are going to measure and what we have to do. So I have explained what is a eyepiece. So here we are having a lens end. So with the help of this lens end only, we are going to get the clear image of the Newton's ring. So the clear Newton's ring is obtained with the help of this lens only. Then we are having two types of the scales here. So here just you can able to see the vertical scale. Vertical scale. So the tops to the bottom. So at the top of this vertical scale, we are having a screw that I have never mentioned here. So no specification I have made for the vertical scale. So if you want to measure the top and the bottom side of the reading, so then we have to consider this screw. But we are going to consider only the left and the right side of the reading. So to find the left and the right side of the readings, we are going to consider only the horizontal screw that I have mentioned here. So you can able to see the screw. So by adjusting this screw, we can make this entire just a traveling microscope setup to move towards left and right. So by adjusting this screw, we can make the microscope moving towards left and moving towards right. By rotating through clockwise or anti-clockwise, we can make the just a setup to move. Then here we are having a horizontal scale. We are having a horizontal scale. So it's a long base scale. The long based scale is called a main scale. Above the main scale, we are having a movable scale. That a movable scale is nothing but the vernier scale. So that I have shown here at the left side. So here in the left hand side, we can able to see the main scale. Main scale, it's on a long scale. It's a fixed scale. Main scale will not move. Main scale be fixed. The only movement is the vernier scale. So the vernier scale is moved with respect to the screw adjustment. By adjusting the screw, we are moving the vernier scale to view the band, to view the fringes, to view the circular rings. So the main scale is a fixed one. The vernier scale is a movable scale. So here we can able to see that in vernier scale, the starting value is 0. This 0 is the reference point. Then we are having just a full value that mentioned as 1. Then we are having another full value. It's mentioned as a 2, 3, 4, 5. So above this order, we can able to see the another parameters also, 6, 7, 8, 9, 10. So dear students, please don't consider these above values. Please don't consider this above range 6, 7, 8, 9, 10. We are not going to consider about this. So only we have to think about this bottom. So we are going to start with the 0, from 0 to 10, then 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So here totally we are having the 50 lines. If you count these lines, if you count these entire vernier scale lines, you can able to see the 50 lines here. This is a total number. So here, this 0 is the reference. So you have to place this 0 at any point. So based on the order. For example, if you are going to consider n plus 3, with the help of this horizontal screw, you have to see here through the eyepiece, and you have to rotate the horizontal screw, and you have to fix the vertical wire to be at the n plus 3rd position. Then you have to see the 0 of the vernier scale. So where it's pointing down, where it's pointed in the main scale. Here the main scale readings are in centimeters. So each division is a 0.05 centimeter. Each division is 0.05 centimeter. So here the 0 where it's entering, that we have to check it. So this is the way. 0 is the reference. The vernier scale 0 is the reference, where this 0 is pointed in the main scale. That value we have to be taken as a main scale value. Once you measure the main scale value, then check the coincidence reading here. We are having 50 lines. Out of these 50 lines, please check whether which reading is exactly coinciding with the main scale. For example, 40th line, this is a 4, vernier scale 4. 4 is the 40. This 40th line is exactly coinciding with the main scale reading, means we have to write the vernier scale value as 40. So this is the way, this is the experiment. Please, someone has just muted your call. Honorable son, unmute. Mute yourself, Honorable son. You are unmuted. Please mute your microphone. Yeah. So actually, this is the setup. As I informed that we are going to consider a wooden frame that you can able to see here. So inside this wooden frame, we are going to place a plain glass plate. Above the plain glass plate, we are going to fix a plano-convex lens. Then these two medium is covered with the glass plate which inclined at an angle of 45 degree. 45-degree inclined glass plate is used as the base. So we are using this 45-degree inclined glass plate to make the light radiation to be reflect, which falls over it. Then the reflected ray will strike the convex lens and then it goes to the plain glass plate. So this the test medium. By using this medium only, with the help of this medium only, we are going to measure the Newton's rings. We are going to obtain the Newton's ring. Wooden frame. Here in the wooden frame, a glass plate is inclined at an angle of 45 degree. Inside these only we are going to place a plano-convex lens under the glass plate. Then this entire setup is fixed or placed in front of the light source. The light falls on these 45-degree inclined glass plate, then it will reflect back, transmit, and then when it falls to the bottom surface, it will again reflected back. Transmitted ray and the reflected ray are superimposed with each other, and as a result, with the help of the eyepiece, we are going to view the interference pattern. So this is the just experimental ring. Here I have shown the orders also. So when you view through the eyepiece, you are able to get like this image. You are going to get an image like this only. So you can able to see a dark line, then a yellow color region, then again a dark ring, then an yellow color region, then again a dark ring. So this is nothing but Newton's ring, interference pattern. So here we have to measure the readings. So with the help of the horizontal screw, we can measure the values from the left hand side, and also we can measure the values from the right hand side. So here I have shown the eyepiece section. The left side of the Newton's ring, you can able to see a circle. So inside this circle, we are having a cross. So here the cross is nothing but horizontal wire and the vertical wire. Blue line is the horizontal wire and the black line is the vertical wire. So we are going to consider only the vertical wire, because these vertical wire only exactly coincide with these end curve. So the starting value, you can able to see. For example, I am going to start the readings from the left hand side. So what I have to do, I have to adjust the traveling microscope horizontal screw. By adjusting the traveling microscope horizontal screw, with the help of the eyepiece section, we have to view it and we have to do the adjustment. So without seeing, we can't do the fixation. So you have to place your eye in the eyepiece section, and your right hand should move. Simultaneously, you have to just see the movement, and you have to fix the position. So here I have taken the horizontal wire. That horizontal wire is exactly fixed at the first circle. So by moving the horizontal screw, the scale also will change. After fixing the position, just measure the value as n. So we have to measure this value as n. N is equal to, we have to see what is there in the main scale with reference to the vernier 0, and what the vernier scale coincidence. So after measuring the value, then again rotate the screw. Fix the position to n plus 3. See the first 1, 2, 3. It became n plus 3. So we are moving the scale by fixing the fringes, by fixing the orders. The scale also tends to change. So that the changes we have to be measured simultaneously. Then after getting the values of n plus 3, with the help of the horizontal screw, again just move the IP section. So fix the vertical wire at n+6. So this is the experimental procedure. We have to move the horizontal screw, and we have to make the vertical wire to be movement. The vertical wire is to be fixed at the desired point. n+3, n+6. So like that, by similar procedure, we can take readings up to n+15 or n+18. So once you completed the left hand side, first to measure the left hand side, for example, if you are rotating your horizontal screw in the clockwise direction, if you are rotating your horizontal screw in the clockwise direction, by rotating the horizontal screw in the clockwise direction, the microscopic section is moving from right to the left side. After completing the left hand side reading, then please give the reverse key. Give the rotation, reverse rotation. For the left hand side reading, you have given the clockwise. Now to get the right hand side reading, we have to give the anti-clockwise rotation. So give the anti-clockwise rotation. Make the vertical wire to be at the right hand side of the first ring. Consider this as n. Then go for the third reading. Consider this as n+3. Then go for another third reading. Consider this as n+6. Similar way, we have to go up to n+15 or n+18. It depends on the examiner. So this is the procedure. A very simple experiment. You have to focus the Newton's ring. Once you obtain this Newton ring, once you can able to see that Newton ring, then the experimental way is very, very easy for you. So here I have shown a small example. How to measure the readings. For example, I have fixed at a n+3, n+3rd position. Here we have shown a 0. Please see that these vertical scale 0. Here we are having 0.1, 0.2, 0.3, 0.4, 0.5. Please don't consider all these points. You have to imagine that 0, 10, 20, 30, 40, 50. That's all. Totally, we are having only 50 divisions, 50 lines. So with these 50 lines only, we are going to measure our calculation. We are going to get our reading. See, the 0 is the reference point. If your vertical wire is in the n+3rd position, for example, this is the position for that particular n+3rd ring. So you have to consider this 0, and you have to see where this 0 is located in the main scale. So here 0 from the main scale, the first point is 0, 0 to 1, 0 to 2. So in between these 0 to 1, we are having 20 divisions. In the main scale, 0 to 1, we are having totally 20 divisions. So the each division is 0.05, 0.05 centimeter. So here is 5. We can able to see that the value is located in between just 0.5 to 0.6. So the exact value here, the reference of these vernier 0 coinciding with the main scale is 0.0. What is this one? Okay, it's just 0.05. 0.55. This one is 0.55 because it is a 5 means it's coinciding with the center point. So 5 plus 0.05 is nothing but 0.55. So this is a main scale. Vernier scale division. So here the vernier scale division is the exact coincidence with the main scale. We can able to see that 40 in the vernier, 40, 41, 42, 43, 44th line is exactly coinciding with the main scale. So we have to consider that the vernier scale coincidence is the 44th division. Then we have to obtain this main scale and the vernier scale values in the formula, total reading formula, to get the final result. So I will show the readings also, and I will show how we are writing these results. See here, as per the previous slide, the vernier scale 0 is coinciding with some value in the main scale. That value is confirmed as 0.55 centimeter. So I have written here as 0.55 centimeter in the main scale. Main scale value is 0.55 centimeter. Here we know that the coincident value is from the vernier scale. The 44th line of the vernier scale is coinciding with the main scale. So you should not consider the main scale reading. For the second case, we have to consider only the vernier. So 44th line is coinciding with the main scale. So I have written here as 44. Sorry. Then vernier scale coincidence became vernier scale reading. Now we have to know the least count here. The least count for this traveling microscope is 0.001 centimeter. So that I have substituted here. Total reading is equal to MSR plus VSC into least count. So the VSC is 44 into least count is 0.001. So by multiplying these two, we get 0.044. This will be the VSR. And finally, the total reading here. So TR is equal to MSR plus VSC into least count. MSR is 0.55 plus VSC is 44 into least count is 0.001. Therefore, we are getting the value TR is equal to 0.594 centimeter. So I have to return here the value, but by mistakenly I have given in the right hand side. So these are the changes. 0.594. So by similar way, by adjusting the microscope, by fixing the order, you have to measure 18, 15, 12, 9, 6, 3, n. So this is the experimental way. So they started from the left end side. From the left hand side, they moved their microscope and they followed towards the right. So this is the experimental way. After measuring these readings, we know the formula R is equal to R square n plus 9 minus R square n divided by 9 lambda. So the difference is 9. So here we have to make the difference of 9 and we have to write the readings here in the diameter. If you know the diameter, by dividing the value, we can write the radius. Then we have to square this value. By squaring this value, we can find a radius square. So this is just a calculation method. If you know this calculation method, then you can give the results easily. So if you have any doubt, you can ask your doubt. So I wish to stop up to this. If you want to ask anything, you can ask it now. Any doubt? Do you have any doubt?
Sir.
Yeah, ma.
Sir, in that table.
Yes.
Sir, the TR is
the total reading.
Yes, sir.
But sir, TR is you write a TR is 0. MSR is
no, actually,
to 0.5.
No, actually, I by mistaken what I did. I have placed that reading in the second side. So it's my mistake. See, not 0, but I have written that value here, MSR. So here in the MSR, I have written that value. But this value, it should be right here in the total side. Okay.
Yes.
So by mistake, I have made this.
Sir, order of the ring, sir.
Order of the ring. So
yes,
you want to know order of the ring.
Okay. N plus 18, 15, then 12.
Yes.
Sir, what is that?
Yeah, I will show this. Wait. Yeah, you can able to see the screen now. Is it clear?
Yes, sir.
Okay. Is the screen is visible?
Yes, sir.
Yeah. See, boys, here you can able to see the Newton's ring. You are seeing the just black and blue, yellow rings here. Black, yellow. So these be the interference circular pattern. So what we have to do, we have to consider both the sides. Here in a Newton's ring experiment, we are going to take readings from left hand side, and also we are going to take readings from the right hand side. If suppose you are going to start your reading from the right hand side, the first ring you can able to see the center. At the center we are having a first ring. So please consider the first corner. Here I have mentioned N. So you have to place the vertical wire. We have to place the vertical wire at this corner by using this horizontal screw. When you start rotating the horizontal screw, the scale value starts to change. The reading changes. So once you fix the horizontal wire at the exact corner of the first ring, then take the value. After measuring the first value N, then rotate the microscope screw, horizontal screw, rotate this horizontal screw and bring this vertical wire at the third position of the ring. So once the first value is considered as a N, then you have to think that for N plus 3, the second one is 1, third one is a 2, and the fourth one is a 3. There you have to fix your vertical wire and you have to change, you have to measure the changes. Similarly, for N plus 6, again rotate the horizontal screw, bring this wire which now at N plus third position to the N plus 6th order by rotation. 1, 2, 3. So 3 lines we have to consider from that position, from that fixed point. So this is the just experimental way. Is it clear now?
Yes, sir.
Any other doubt?
Yes, sir.
Okay. Any other doubt?
Sir, N plus 9 means the standard.
N plus 9 means if just your position is on the right hand side, you are measuring the readings from the right hand side. So you can able to see that N plus 3, N plus 6. So you have to again rotate the horizontal screw and you have to bring the vertical wire here on the right hand side of these N plus 6. 1, 2, 3. So like that, we have to go forward in the increasing way. Is it clear?
Yes, sir.
Yes, sir.
Any other doubt?
Oh, sir.
Okay, when we are doing
No,
this
sir.
experiment in the laboratory, that time you can come to know what are the changes. So now we are giving the demo only. So you have to know only the procedure right now. If you know the procedure, then doing experiment will be very easy for you. So we people are there to adjust and to focus. So we just give you the complete focusing on the time when you are doing your experiment. So then you have to follow the procedure, what we are saying now. Position you have to fix and you have to measure the correct reading for that position. Okay, if there is any no doubt, so we can wind up our class. Thank you all.
Thank you, sir.
Thank you, sir.
One more thing.
Yes,
General, just this be the general instruction. I have given the second assignment. I have already given the first assignment. So till date, I never received more numbers of assignments from the students for both 1 and 2. nearly 90% of your answer script are completely evaluated, and I have assigned marks also that you have seen that. So there are one or just two from each department or not submitted your marks sheets, marks paper, that is answer script till date. So those who are not submitted your answer script, first you submit your answer script right now, because we are not collecting your data directly from you. So you are sending your data. You are sending your data, so that we are receiving it. So once I inform you to submit your assignment, so that time you submit it, because daily I am seeing that some students are sending their assignments through WhatsApp. So it's difficult for me to collect your assignments from WhatsApp to my email ID. So I have to spend some more time to doing that. So better you people just wait. After completing your marks assessment, Cat 1 marks is completely over means I let you inform to submit your assignment number 1 and assignment number 2 as a soft copy through your mail. So when you are submitting your assignment, as I already informed that in your mail, in your subject page, please mention your name and roll number and the department. So the most of the students are not mentioning it. So it will be a very difficult for me to get and to check and to place that paper in that relevant position. So please, these things only I have to inform in general. So follow these and get ready with your converted PDF. Assignment 1 and assignment 2. Please convert these both as PDF and get ready with this copy. Once I ask you to submit, that time you have to submit it. Okay?
Okay, sir.
Okay.
Yes, sir.
Thank you. Okay, thank you all. Okay, you can leave now.
Thank you, sir.
Sir,
Thank
Yes.
you, sir.
Yes.
sir, myself Mukesh Kumar, sir, from
Yes,
AAA batch.
Mukesh. Okay.
Sir, I had submitted my papers, but the PDF that you sent, my name is highlighted on the red color.
Just a minute, Mukesh. Just a minute. I will check it and say. Huh?
Okay, sir.
You are from Tribute department, huh?
Yes, sir. Sir, I had submitted through my camo on the day of the exam itself.
Sir, me too, sir. But I didn't get my marks.
Wait.
Me too, sir.
Yeah, one by one. First, Mukesh Kumar, say, tell me your roll number.
Sir, AEE20012.
Chettiar Mukesh Kumar.
Yes, sir.
Mukesh Kumar. Just I never got your answer script in Cameo.
Sir, but I had submitted and I have a photo also.
You have submitted. For you, it shows that the status is submission. Okay.
Yes, sir.
Just a minute. I am having the proof also. Tribly, huh? Department is Tribly.
Yes, sir.
See, you can able to see the screen. No. You can able to see the screen, huh? Mukesh.
Yes.
Yeah.
PDF is on, sir.
Yeah. See, what can I do? I have downloaded. I have got only these two papers. You can able to see that answer link also here. From your side,
So
yeah, from your side it's uploaded properly, but for my side it's not received. Okay.
sir, so from where should I send it to you?
Yeah, you send me to my mail ID.
Through email?
Yeah, through
Okay,
email.
sir.
Yeah, through email. So that only I have highlighted and I have mentioned. Okay. So the students, I have taken all the documents. You can check these also. See here, I have received only two papers. Jayavel and Shaktishwari. See, the students are trying to upload it, but it's not properly uploaded. So that's the reason. For your side, it shows that. Yeah, another one who?
Mining Jagdishwaran, sir.
Mining Jagadishwaran. mining Jagadishwaran, you see that
இமெயில் சென்ட் பண்ணேன் சார் உங்க இமெயில்ல.
email. Okay, email நான் பாத்துக்கிறேன். பட் நீங்க
Sir.
கேமியோல சென்ட் பண்ணது வரல.
நான் தான் இமெயில்ல தான் சார் சென்ட் பண்ணுவேன்.
இமெயில் சரி நான் செக் பண்றேன். இல்லன்னா திருப்பி ஒரு போடுங்க. அதுல என்ன இருக்கு?
சார் உங்களுக்கு 3 முறை அனுப்பிச்சிருக்கேன் சார். நான் உங்களுக்கு ஃபோன் கொடுக்கிறேன்.
இல்லப்பா, இது கால்ல அனுப்பிட்டியா?
எஸ் சார்.
ஓகே
இன்னைக்கு காலைல
ஓகே நான் பாத்துக்கிறேன். எனி அதர்?
சார் நான் கூட அனுப்பினேன் சார். நேத்து கூட ஒரு 2 டைம்ஸ் மெயில் பண்ணேன். அதுக்கு முன்னாடி மை கேம்ல 5 டைம் அப்லோட் பண்ணேன் சார்.
உங்க நேம் தம்பி?
சார் முத்துராஜன் சார், நேவல் டிபார்ட்மெண்ட்.
நேவல் டிபார்ட்மெண்ட் முத்துராஜன். நான் செக் பண்றேன்.
ஓகே சார், தேங்க் யூ so much சார்.
ஓகே. எனி அதர் டவுட்? முத்துராஜன் நான் மார்க் போட்டுறவா?
சார்
சொல்லுங்கம்மா. டெல் மீ.
சார் நீங்க தான் சார் கூப்பிட்டீங்க என்ன?
முத்துராஜன் மார்க் போட்டோம் உங்களுக்கு.
எவ்வளவு சார் வந்தது?
எவ்வளவு வரணும்னு ஆசைப்படுறீங்க?
45 பிளஸ்
40 போட்டுருக்க. 40.
ஓகே சார்.
ஓகே.
தேங்க் யூ சார்.
ஓகே. ஓகே, is there any doubt?
சார் நான் இப்போ பிடிஎஃப் சென்ட் பண்ணேன் சார். வந்துச்சுன்னு செக் பண்ணுங்களா?
நானும் மெயில் பார்க்கலாம் தம்பி. உங்க பேர்?
முகேஷ் குமார் சார்.
நான் பாத்துக்கிறேன்.
ஓகே சார்.
ஓகே, thank you all.
தேங்க் யூ சார்.
ஓகே.
சார்.
எஸ்
சார், சுதர்சன் பேசுறேன் சார்.
சொல்லுங்கம்மா.
நான் இன்னைக்கு தான் சார் ஜாயின் பண்ணேன்.
இன்னைக்கு தான் ஜாயின் பண்ணீங்களா? நான் உங்க வாட்ஸ்அப் குரூப்ல ஜாயின் பண்ணிக்கோங்க. நீங்க
எந்த குரூப் சார்?
நீங்க ட்ரிபிள்